Okay, in this problem, you're given the time and the velocity over a 3-second interval, and the seconds there give you half-second intervals. And you're asked to compute R6, L6, and M3. So it might sort of help to have you, graph or sort of plot this. 1.5 to 2.53. And so it looks like we go up to 25. So I'm going to count by fives: 5, 10, 15, 20, 25. Okay, so at 0.5, so this is 0.5, 1, 1.5, 2, 2.5, 3. Okay, at 0.5 you're at 12, so you're about here. And then at 0 you're at 0. And then from 0.5 to 1 you're at 18. So maybe 18 will be about here. And at 1.5 you're at 25. And at 2 you're at 20. And 2.5 you're at 14. And at 3 you're at 20. So at 3 we're back at 20. So you can kind of imagine the graph, just sort of like, think of it smooth because it's some sort of thing traveling. So maybe it looks something like that. So you want to estimate the area under that curve, and one way they want you to do it is with R6. Well, R6 is going to be delta x times f at a plus, R6 is delta x, the sum, I goes from 1 to 6, f at a, which is 0, the starting point, plus I delta x. And but your delta x is 0.5. So what you want to imagine is that you're looking at the right-hand intervals. So you're going to use as your height the right-hand intervals. So the right-hand endpoint of these subintervals. And see how you have 6 rectangles? 1, 2, 3, 4, 5, 6. And the height that you'll get for your rectangles is going to be the right-hand endpoint. So your delta x here is the length of the subinterval, which is 0.5, times, the right-hand endpoint for each subinterval. So for this first one, what's the value at 0.5? It's 12. And then for the second interval, the value at 1 is 18. And then at 1.5, you have 25. And at 2, you have 20. At 2.5, you have 14. And at 3, you have 20. So you'll just add those up and then take half of it. And I'm going to let you do that because I only have 5 minutes. So just find that answer. Now, L6, all you're going to do is use the left-hand endpoint. So you're going to do the delta x, which is 0.5. But now your height is going to be like the first one, there's going to be no area. But then the second rectangle is going to have this as its height. And the third rectangle is going to look like this. So maybe you can see I'm doing them in red now. So those would use left-hand endpoints as the height. So the first point would be 0. The first height is 0. The second height for would be the 0.5. So you're going to do the 12, and then the 18, and then the 25, and then the 20, and then the 14. But notice you won't, on this interval, let's see, you're going to do this one. And on this interval, you're going to do this one. And then on this last interval, you're just going to use the value at 2.5, which was the 14. So you can just go ahead and compute that. And then for M3, you're only going to have 3 subintervals. So it's going to be, I'll do it in yellow, this one, and this one. So your midpoints are going to be at the 0.5, the 1.5, and the 2.5. But the length of your interval now is 1 unit. So you're going to do 1, the delta x is 1, and then the height at 0.5, 1.5, and 2.5. So 12, 25, and 14. And then that's going to be an estimate for your distance traveled as well.